Okay, guys, welcome to section 4.3. Today you're learning a new, I'll say, exponent law or exponent rule. You are learning about fractional exponents, or as we call them, rational exponents. They're really not too tough once you get the hang of it. It is essentially saying that we can write any radical or root as an exponent or as a power where the exponent is a fraction. So something with a root sign, if this is a 2, would be a to the exponent 1 over 2. If this was 3, it would be a to the exponent 1 over 3. So anything with a root sign is really a fractional exponent. Sometimes we can have mixed fractional exponents. Oh, that came out wrong. We can have a fractional exponent where one of the values is not a 1, so you can have like 2 over 3. The number on the denominator of your exponent is the root. Okay, the m is on the outside. So in a way, you can kind of think of it like a to the 1 over n to the exponent m. So just relating it up to the top, this part would be your root, and then the m is on the outside. So you end up with this, okay? And you can write it either way. Okay, so just keep in mind, you can't have a negative under a root sign. You can't evaluate it of it. So some of them won't have real solutions. You can still do some of the math. You just can't get a full solution at the end. Okay, all right, let's just do a whole bunch of examples, and then you can try your questions on your own. And no, I'm not doing all of them today. So 16 to the exponent 1 over 2, just to give you an idea of what this would look like. This is really the square root of 16. So you put the denominator out in the front of the root sign. We all know how to take the square root of 16. It is 4, right? Because 4 times 4 is 16. Now, something like this, just to show you, we can have a negative. So again, the 2 is on the bottom of the fraction, which gives us a root 2. We have a negative 1 over negative 16 underneath the radical sign or the root sign. You can't take the square root of a negative number, so this can't be done. Okay. But let's take a look at this one. This also has a root sign, but the bottom of my fraction is a 3. Okay, so the cubed root of negative 216 squared. Okay, and yeah, you're probably going to notice me pull my calculator out a few times today because I don't want to screw it up. Even though this is a negative, the cubed root of a negative number, I do actually get a value, okay? Because, and if you can see my fingers up here, okay, negative times a negative is positive, times another negative gives you a negative answer. So if the bottom number of your fraction is odd, it is okay to have a negative under the root sign. Okay, so you can continue on with your expression here. So negative 6 squared is is positive 36. Okay, negative times negative is positive. Okay, and then if you happen to see things like this, guys, they're just your fraction rules again from elementary school. You can use them to simplify, and it goes back a little bit from yesterday's work. So you'll notice that this power is being divided by this power at the bottom. So I'm going to subtract my exponents to make my simplifying a little bit easier. So you're going to have 2 over 3 minus 1 over 2. You should get 5 to the exponent 1 over 6. That would be the 6th root of 5. Now from here, I would prefer if you left it as a radical sign, but if you have to, you can try plugging it in on your calculator. Oops. Oh yeah, that was the right one. And I get 1.30766. Okay, so 0766, 077. We'll round a bit. Okay. Now, if you need to plug that in on your calculator, you should have a button that looks something like that. Okay, so look for a button on your calculator that might be like that. If not, you're going to have to use the fraction button combined with your exponent button. Okay, so play around with your calculators, make sure you can do that. Okay, so you can pause your video, make sure you're getting the right answers, and then you can move on. Okay. And again, these are all just a whole bunch of different examples with negatives in different spots and different roots. to make sure that you guys are capable of handling these. Okay, so let's skip this one. Let's go to this guy over here. So I have 16 to the negative 3 over 4. The negative is in the exponent, which means eventually you're going to have to take the reciprocal of your base. But let's play around with this first. The denominator is going to go out front. So this is going to be the 4th root of 16 raised to the negative 3. The 4th root of 16 is 2. So this is 2 to the negative 3. I'm running out of room, so I'm just going to continue it here. A negative in the exponent flips the base. So I'm going to take the reciprocal of the base to give me 1 over 2. And now my exponent becomes positive. 1 to the exponent 3 is 1. 2 to the exponent 3 is 8. Okay, so remember this 3 applies to everything inside the brackets. And this would be your answer, 1 over 8. We're going to skip number 5. I just want you to realize if we brought the 2 out front, you would have the square root of a negative number. You can't have that, so you wouldn't be able to do that one. Okay. Let's take a look at something with a fraction. Okay, we're just going to do a positive one. I'll take a look at this guy here. 16 over 27. Okay, the 2 goes out front. Actually, you know what? We're going to do number 8 because I want to show you everything. So the 3 goes out front, right, the bottom of the fraction. So this is the cubed root of 27 over 64. And the square is on the outside. Now, the cubed root of 27 and the cubed root of 64, they're both under the root sign. So the cubed root of 27 is 3 because 3 times 3 times 3 is 27. The cubed root of 64 is 4 because 4 times 4 is 16, 16 times 4 is 64. Okay, so the cubed root of these guys is 3 over 4. I still have this whole thing to be squared at the end. So 3 squared is 9, 4 squared is 16, and you've finished evaluating that without a calculator. Okay, that's pretty much it. If you need more examples, go into your book, and good luck with the section.